Chapter 3, Circle. Now you know what is a circle. Everybody knows what is circle. How to draw a circle. To draw a circle we require this here. We require center and we also require radius. Okay. With the help of center and radius we can draw a circle. Now students, secant and tangent. What is secant and what is a tangent? Now in this figure, A is center of circle and line L is there. In second figure, B is the center of the circle and line M is touching the circle at the point P. Okay, in the first figure, the line L is not touching the circle. In the second figure with the center B, circle with center B, the line M is touching the circle at the point P, and here in the third figure, the circle with center C, the line N is intersecting the circle in 2 points Q and R. Correct, students? So here line M is intersecting the circle in 1 point only. Line M is intersecting the circle in 1 point P. Therefore line M is called a tangent. It is called a tangent line. A line which intersects the circle in 1 point is called a tangent line. So here line M is a tangent. In this figure, the circle with center C, the line N intersects the circle in 2 points Q and R. Line N intersects the circle in 2 points Q and R. Therefore we can say that line N is a secant. Line N is a secant, a line which intersects the circle in 2 different points. A line which intersects circle in 2 different points is called a secant. So here line N is the secant, and here in this figure a line which intersects the circle in 1 point only is called a tangent. So line M is a tangent. In the figure above, not a single point is common in line L and the circle with center A. Here line L and circle with center A does not have any common point. Point P is common to both the line M and the circle with center B. Here line M is called a tangent of the circle and point P is called the point of contact. Point P is called the point of contact and line M is called the tangent. Now 2 points Q and R here. 2 points Q and R are common to both the line N and the circle. This Q and R is also lies on the line N and it also lies on the circle. Q and R are intersecting points of line N and the circle. Line N is called the secant of the circle. So all of you understood what is a tangent and what is the secant. Both are lines. Okay. Now there is a theorem, tangent theorem. Okay students. Now students, I am going to explain what is tangent theorem. Okay, theorem. A tangent at any point of a circle is perpendicular to the radius at the point of contact. Now this theorem is a very important theorem. Its application is very important. In majority of sums you can see that this theorem is applied. What is tangent theorem? The name of the theorem is tangent theorem. Theorem. A tangent at any point of a circle is perpendicular to the radius at the point of contact. In short, I can say that tangent is perpendicular to radius. I can say that tangent is perpendicular to the radius. What is tangent theorem? A tangent is perpendicular to the radius at the point of contact. So what it means? In this figure, O is the center of the circle. Okay, this line L is intersecting the circle at point A and OA is the radius. Okay, so in the figure O is the center of the circle, line L is intersecting, is a tangent line and it is intersecting the circle at point A. Now this theorem, what this theorem means, it says that the tangent, this line L, is perpendicular to the radius. Line L is perpendicular to the radius. ये आपका रेडियस है, OA रेडियस है आपका, ओके, और लाइन L जो है वो टेंजेंट है, और ये A जो है वो पॉइंट ऑफ कांटेक्ट है. तो ये थ्योरम कहना चाहता है कि जो लाइन L है, टेंजेंट जो है वो रेडियस को परपेंडिकुलर है. कहाँ पर परपेंडिकुलर है? पॉइंट ऑफ कांटेक्ट पे. कहाँ पे परपेंडिकुलर है? टेंजेंट रेडियस को पॉइंट ऑफ कांटेक्ट पे. तो थ्योरम कहता है टेंजेंट is perpendicular to the radius at the point of contact. Now students, we are not going to prove this theorem, okay, because there are some theorems which are going to come in exams. I'll explain that theorem in details, and this theorem from exam point of view, it doesn't comes in the exam. Therefore just application, you understand the application, how to apply this theorem. So what the theorem means, a tangent is perpendicular to the radius at the point of contact. So in the figure I can say that line L is a tangent to the circle with center O at the point of contact A. And what to prove? Line L is perpendicular to radius. So what you have to remember, line L, the tangent is perpendicular to radius. Tangent is perpendicular to radius. What you have to understand from this theorem, tangent is perpendicular to the radius. Understood everybody? Now we have a theorem, converse of tangent theorem. Tangent theorem का उल्टा, उसका opposite, converse of tangent theorem. What this theorem means? What this theorem says? Theorem: a line perpendicular to a radius at its point on the circle is a tangent to the circle. Now it means that if line L is perpendicular to the radius, if line L is perpendicular to the radius at the point of contact, then we can say that line L is a tangent. तो यहाँ पे हमें tangent proof करना है. अगर कोई line, if any line is perpendicular to the radius at the point of contact, we can see that N is the point of contact of the circle and the line L. लाइन L और सर्कल कहाँ पर मिल रहे हैं? M पे, N पे मिल रहे, पॉइंट N पे मिल रहे हैं, इसलिए पॉइंट N को कहा जाता है पॉइंट ऑफ कांटेक्ट. ये लाइन L और सर्कल कहाँ पर मिल रहे हैं? N पर, तो N को कहा जाता है पॉइंट ऑफ कांटेक्ट. तो ये थ्योरम कहता है कि इफ अ लाइन इज परपेंडिकुलर टू द रेडियस एट द पॉइंट ऑफ कांटेक्ट, देन दिस लाइन L इज ए टेंजेंट. ओके, तो ये थ्योरम भी आपको याद रखना है. सिर्फ M is the center of a circle, segment MN is the radius, line L is perpendicular to segment MN at N, therefore we can say that line L is a tangent to the circle. Any line which is perpendicular to the radius at the point of contact, then that line is called a tangent. Now in the next this exercise, practice set 3.1, we are going to use these theorems. Now we have another theorem. It is called tangent segment theorem. It is called tangent segment theorem. Okay, now what this means? Now students, now you can see here in this figure, point P lies on the circle. Okay, here in this figure, point P lies on the circle, है ना? Then how many tangents can be drawn? We can draw only one tangent, okay, passing through the point P. If a point lies on the circle, then from that point we can draw one and only one tangent. If a point here in this figure, point P lies on the circle, how many tangents can be drawn here? Only one tangent, one and only one tangent. Okay students, now in this theorem, if the point is outside the circle, you can see here, this is a circle. Now point D does not lie on the circle, it is lying in the exterior of the circle. सर्कल के बाहर lie कर रहा है point D. तो हम पॉइंट डी से 2 टेंजेंट्स ड्रॉ कर सकते हैं स्टूडेंट्स। कितने टेंजेंट्स ड्रॉ कर सकते हैं? 2 टेंजेंट्स। एक है डी पी, देख सकते हैं पी डी कह सकते हैं आप उसको। डी से आप एक अगर टेंजेंट ड्रॉ करोगे तो वो सर्कल को पॉइंट पी पे इंटरसेक्ट कर रहा है, और यहाँ पर अगर डी से आप एक टेंजेंट ड्रॉ करते हो तो वो पॉइंट क्यू पे इंटरसेक्ट करता है। और डी से हमने ए ड्रॉ किया लेकिन ये टेंजेंट नहीं है। टेंजेंट का डेफिनेशन क्या है? ए लाइन विच इंटरसेक्ट्स द सर्कल इन वन पॉइंट इज कॉल्ड द टेंजेंट। तो अगर कोई पॉइंट सर्कल के आउटसाइड द सर्कल है, इट इज अलाइंग इन द एक्सटीरियर ऑफ द सर्कल outside the circle, then from that point how many tangents can be drawn? 2 tangent segments can be drawn. One is dp and one is dq. Okay students, so now what this theorem means, what this theorem says? Tangent segment theorem. Tangent segments drawn from an external point to a circle are congruent. Tangent segments drawn from an external point to a circle are congruent. Now dp and dq are the tangent segments drawn from the external point D. We have to prove that PD, dp and dq are congruent. ये हमें prove करना है. Now in this figure, A is the center of the circle. Segment dp and segment dq are tangents to the circle at the point P and point Q. We have to prove that segment dp and segment dq are congruent. To prove this theorem, we require a construction. Draw segment AP, draw segment AQ and draw segment AD. AD को भी हमें ड्रॉ करना है, दिया नहीं था हमें। तो AP कंस्ट्रक्ट करना है, AQ कंस्ट्रक्ट करना है, AD कंस्ट्रक्ट करना है। नाउ बिकॉज ऑफ दिस कंस्ट्रक्शन वी गेट 2 ट्राइंगल्स। नाउ स्टूडेंट्स, हमने सबसे पहला थ्योरम क्या पढ़ा था इसका? टेंजेंट थ्योरम। क्या थ्योरम था वो? अगर DP टेंजेंट है तो और AP रेडियस है तो टेंजेंट विल बी परपेंडिकुलर टू द रेडियस। तो टेंजेंट इज परपेंडिकुलर रेडियस, तो वी कैन से दैट ये 90 डिग्री बन जाएगा। और यहाँ पर DQ टेंजेंट है और AQ रेडियस है। टेंजेंट थ्योरम कहता है टेंजेंट इज परपेंडिकुलर टू द रेडियस, तो यहाँ पे भी 90 डिग्री बन जाएगा। नाउ ये दोनों राइट एंगल ट्राइंगल्स है। कौन से ट्राइंगल्स है स्टूडेंट्स? राइट एंगल ट्राइंगल्स। दोनों में 90 डिग्री है। आप देख सकते हैं ट्राइंगल PAD में भी एंगल P 90 डिग्री है और ट्राइंगल QAD में एंगल Q 90 डिग्री। Q 90 डिग्री है और P 90 डिग्री है, दोनों 90 डिग्री, देयरफॉर राइट एंगल ट्राइंगल हुआ। नाउ अब हमें ये दोनों को प्रूफ करना है, DP और DQ को कॉन्ग्रुएंट प्रूफ करना है। तो स्टूडेंट्स, दे आर द साइड्स ऑफ 2 ट्राइंगल्स नाउ। फॉर द सर्कल दे आर टेंजेंट सेगमेंट्स, फॉर द ट्राइंगल दे आर द 2 साइड्स। नाउ वी हैव टू प्रूव 2 sides of a triangle congruent. Now what we will do is we are going to prove these 2 triangles congruent. If 2 triangles are congruent, then their remaining sides are also congruent. If 2 triangles are congruent, then the remaining sides are also congruent. So we are going to first of all prove that the 2 triangles are congruent by hypotenuse side test. Which test? Hypotenuse side test. Now here you can see, students, A is the center of circle. Therefore I can say that AP is radius and AQ is also radius. Okay, and we know that radius of the same circle are congruent. So I can say that AP and AQ are congruent. Okay students, and AD is common to both the triangles. Segment AD is common to both the triangles. So segment AD is congruent to segment AD, but AD is the hypotenuse. What is hypotenuse? The side opposite to 90 degree. So AD is hypotenuse for triangle PAD and AD is also hypotenuse for QAD. Correct students? Therefore I can say that in these 2 triangles hypotenuse is congruent to hypotenuse and a side is congruent to side. Therefore the 2 triangles are congruent by hypotenuse side test, and if 2 triangles are congruent, then the remaining sides are also congruent. Therefore I can say that segment DP is congruent to segment DQ. How to prove this? See here, I have written here proof in my style. Proof, number, statement, reason. First point, in triangle PAD and triangle QAD, segment PA is congruent to segment QA, radii of the same circle. Segment AD is congruent to segment AD, common side angle APD is equal to angle AQD is equal to 90 degree. Tangent theorem. Therefore, triangle PAD, second point, triangle PAD is congruent to triangle QAD by hypotenuse side test. Therefore, if two triangles are congruent, then the corresponding sides of congruent triangles are also congruent. Corresponding sides of congruent triangles. The full form of CSCT is corresponding sides of congruent triangles. Now here two triangles are congruent. We have proved it by which test? Hypotenuse side test. You in 9th standard आपने पढ़ा होगा. Different tests are there. SAS test, SSS test, ASA test, SAA test and hypotenuse side test. उसमें से मैंने hypotenuse side test यूज़ किया, अप्लाई हुआ यहाँ पर. ट्राइंगल PAD और ट्राइंगल QAD कॉन्ग्रुएंट है, इसलिए हम कह सकते हैं कि सेगमेंट DP एंड सेगमेंट DQ भी कॉन्ग्रुएंट है. रीजन करस्पॉन्डिंग साइड्स ऑफ कॉन्ग्रुएंट ट्राइंगल्स. Hence proved that the tangent segments drawn from an external point to a circle are congruent. So this theorem is also very important theorem, students. Tangent segment theorem. The statement is tangent segments drawn from an external point to a circle are congruent.